rational, just a basic rational function. You can see that some things cancel out. We're going to have a vertical asymptote that doesn't cancel. But one thing before we start this here, I want to make note of. Okay, this is something that when we have a factor, a linear factor in the bottom that is an odd power. Okay, so we're going to have a vertical asymptote, and it's going to point in opposite directions across that asymptote. If I have a factor that is an even power, for example, squared, well, squared's going to bounce like that. And remember that when we had bounces like that, the asymptotes went in this direction, okay, when we did a reciprocal function. So that's what's going to happen here. So when we have a vertical asymptote here, would be at x equals 2, and the factor squared, what's going to happen is I go from one side of 2 to the other. I'm going to go from negative squared to positive squared. Well, both of those are going to go to infinity. Okay, so that's what the graphs are going to look like when I have squared factors versus the odd factor. Because as I go from the negative side of 1 to the positive side of 1, I end up with a negative 0 to positive 0. Well, negative 0 goes down to negative infinity, divided by positive 0 goes up to positive infinity. Okay, so those are a couple things that you should make note of, and we want to use that idea then. Okay, so we're going to apply that here. So when I cancel these out, I'm going to have a hole at x equals 4. Plug the y in. 4 is going to be 27 divided by 3 squared is 3. Okay, so 27 divided by 9. And we have a vertical asymptote at x equals 1. But notice that that is a squared factor. So what's going to end up happening is it's either going to both point up on both sides or point down on both sides. Okay? So this is something that we have to be now consider because of that squared factor. So let's find our zeros here. We have a 0 at negative 2. It's going to cross the x-axis here. As I let x get really, really big, okay, the limit as x goes to infinity, both positive and negative, it's going to do the same thing. It's going to both go to 0. So I've got a horizontal asymptote at 0. I should figure out my derivative here. So I'm going to differentiate this. So f prime of x, that's going to be 6 times x minus 1 squared minus 6x plus 3, 2x minus 1. And that's going to be all over x minus 1 squared squared. Okay, so I can get rid of some of those factors. So I end up with 6x minus 1. This is going to be minus 2 times, so plus 6x plus 3, and that's going to be over x minus 1, and we're going to have to reduce that power by 1. Solving this, 6x minus 12x is negative 6x. Negative 6 minus 6 is negative 12. Okay, so my derivative, I'm going to have a non-permissible value here. Okay, this is equal to 0 at x equals negative 2. I should really factor that, but it's going to be negative 6 times x plus 2. Okay, so at x equals 2, y equals, when I plug the 2 in, negative 2 in, I'm going to get negative 12 plus 3 is negative 9, divided by 9 is 1. Okay, so that's going to be where my max is going to be, or min or max. Okay, so I'm going to go to negative 2 here. Okay, at x equals negative 2. And I'm going to have a horizontal tangent. Now, I just realized that solving for the 0 here, it's not at x equals 2, negative 2. It's going to be x equals negative 1/2. There's where my 0 is going to be. Okay, so it looks like it's going to kind of come down and maybe go back up to, it's hard to tell. I'm going to have to test my slopes here. So plug in your slopes, f prime, -3. When I plug -3 into here, I'm going to end up with positive 18, positive. That's going to be negative. So it's going to have negative slope going down. Okay, it's going to come across f prime at -1. When I plug -1 in here, I'm going to get 6 minus 12, negative on top. -2 cubed is negative on bottom, so it's going to be plus. So it's coming up like that to the asymptote. Okay, on the other side of the asymptote, f prime of 1, I'm going to end up with negative on top. I should plug in here. This is not 0, this is 1, isn't it? Okay, so I need to choose a number on the other side of 1. I'll choose 2. So I'm going to end up with negative on top, positive on bottom, so it's going to be negative. Okay, so it's going to be pointing down like that. Okay, so when I graph this then, I've got my coordinate here. I've got at -2, -1, or -2 and +1. Is that true? Let me just double check. -2 is going to give me -12, plus 3 is -9, divided by 9, that should be -1. Okay, it should be down here. There's my coordinate. Okay, so when I draw this in, it's got a horizontal asymptote, comes through the midpoint, comes through the 0, up to the asymptote. This has an asymptote here, and it has an asymptote along the 0. So there's my graph. So the note here was the f prime of x equals 0, and a sign change has to occur for a minimum to occur. So notice that there's a sign change across this, so that must be a minimum occurring at that point.